Okay, section 5.4, problem number 5. This is a rational inequality. As long as you're comparing to 0, life is a lot easier. So even when it's not compared to 0, rearrange it until you get it compared to 0, especially if you're dealing with an inequality. X plus 4 over x minus 1 when is that less than 0? Let's think about this and let's talk about it. And they ask you to do some of this very algebraically. Instead of zeros, we refer to them in inequalities as critical numbers, and that's where the top or the bottom would equal 0. So negative 4 and positive 1 would be our two critical numbers. And negative 4 and positive 1 break down your number line or your x-axis into three different intervals. One from the negative infinity to negative 4, and then from negative 4 to 1, and then from 1 to infinity. That's where your three intervals are broken down based on these critical numbers. And you choose a number within that interval. The negative 5 is within that interval. You plug it in and you get positive 1/6. So that's a positive number. That means that part's going to be above the x-axis. Plug in something from negative 4 to 1. 0 is always great. You plug in 0. 4 divided by negative 1 is negative 4. It's negative. So within that interval, from negative 4 to 1, you're getting a negative answer. It's going to be below 0. And from 1 to infinity, you can just use 2. You end up with the number 6. So that's a positive number, so it's above the x-axis. The problem wanted to know when it was less than 0, in other words, where it was below or giving you negative answers, and that would have been in this middle interval from negative 4 to positive 1 is where that would have been. And here's the graph kind of it showing this location right here is negative 4, and then you have an asymptote at 1. So between negative 4 and positive 1 is where you're going to be below the x-axis. So that will work it